Before we move on to the video, if you are looking for more LEED study material, please do not hesitate to contact me on my email and on my LinkedIn. In addition to the material, I have also developed a file in which I have put all the credit categories with their respective names, adaptations to which they apply, their description, their details, furthermore required documentations, formulas, and the standards they follow in a tabular form and color-coded. And all the important terminologies related to that credit categories are stated below. Feel free to contact me and I'll be more than happy to share all with you. Energy and atmosphere, the category in which you can earn maximum number of points, 33 points for all adaptations, for school 31, and for healthcare 35. If you remember in the pie chart of impact categories, the biggest one was climate change, or to reverse the climate change. When you are focusing on energy and atmosphere, you are doing exactly or serving the same purpose. If you reduce the energy use, which is produced by coal, oil, and gas, which in turn releases carbon dioxide and other greenhouse gases in the atmosphere. So reduction of energy is reduction in the GHGs or greenhouse gases in the atmosphere, serving the purpose of stopping, reducing, or reversing the climate change. In addition to that, the U.S. Energy Information Administration estimates that residential and commercial buildings are responsible for approximately 41% of total energy use in the U.S. The EPA estimates that the energy used by the commercial and industrial buildings in the U.S. is responsible for about $400 billion in annual costs and creates nearly 50% of the national emissions of greenhouse gases, contributing to the global climate change. Green buildings help reduce the impact of energy use through reduced energy loads, increased efficiencies, and utilization of clean, renewable energy resources. This is the table which shows the prerequisites and credits, and just like we saw in water efficiency, there are some respective credits to prerequisites: fundamental commissioning to enhanced commissioning, minimum energy performance to optimize, and so on and so forth. So we're going to have a look at it one by one in detail, and I'll try to discuss the prerequisite and credit one after another. PR1, fundamental commissioning and verification. Consider commissioning as a confirmation or verification of whatever systems and equipment you are using in your project, that they are working as they were planned. The intent is to ensure that projects design, construction, and operation meet OPR, that is owner program requirements, from IP credit for energy, water, indoor environmental quality. Indoor environmental quality deals with the HVAC part, water with the plumbing part, and energy for the electrical part. That's why the requirement is that MEP system should be commissioned as per ASHRAE and HVAC as per the standards. MEP, mechanical, electrical, plumbing; ASHRAE, American Society of Heat, Refrigeration, and Air Conditioning Engineers; HVAC is heat, ventilation, air conditioning, and refrigeration, and these are the standards they need to follow. Now, the people who are in the construction industry, I'm sure they know that there are certain procedures or certain steps for commissioning. So commissioning agent should review OPR and BOD. You review that what were the program or owner requirements and what was the design made based on these requirements, basis of design. We discussed the integrative process credit. Then they develop and implement a commissioning plan. Now, this would be our plan, and this is how we are going to implement it. The checklist is same like the LEED scorecard. You have certain things that you need to confirm. You put it in a sort of a list, and then you tick mark whatever is done or not done, or whatever your remarks are. Testing procedures, standard procedure testing for MEP systems, pre-functional performance testing, where you are the kind of equipment or system is not fully functional, but you can still see the drawbacks, or if there is anything missing, and you write it down in the issue log. Then comes the final performance testing, when everything is put in place the way it should be, and you run sort of the final test after clearing the issue log for sure. You verify that the system is running as planned after final performance testing, and you prepare the final report for the owner. Now, commissioning agent could be a third party because it's in the interest of the owner to have a third party in place. If the contractor who has implemented the system, he has an interest to bypass small things just to cover whatever he has done wrong. So a third party commissioning agent would be feasible for the owner in the sense that he would not be biased at least. It could be a third party consultant hired by owner, employee or the owner of the owner, or in some cases a member of the project team. He could be a member of the project team who did not work on this project or who does not have an interest to influence in this project. To remember, firefighting system, building envelope, life safety and alarm systems are not part of this fundamental commissioning and verification prerequisite. For the documentation, OPR and BOD should be submitted, the systems you are commissioning should be submitted, and commissioning plan based on which you will be commissioning, and documentation of testing and commissioning, the final documentation that you made, O&M or operation and maintenance plan, and the final report. So the whole concept is that you get the OPR and BOD, the design requirements, you confirm that the systems are working as they should. If there was any problem, you have rectified that and you have moved forward given the operation and maintenance plan to the owner who hired you only for this purpose. Credit number 1, enhanced commissioning, 3 to 6 points for all adaptations. Whenever a credit is related to a prerequisite, the intent is the same, but the requirements are more stringent or more demanding. So the options here are, there are two options. Option number 1 gonna get you 3 to 4 points. The first one is enhanced system commissioning. Consider this situation compared to the previous one where now we have a whole company or a consultant on board on site who are responsible only for commissioning. So in that case, the system of commissioning would be detailed. There would be submittals. There would be recording. There would recording of all the documents. There will be proper documentation, filing, etc. There are training. So complete commissioning process for MEP. The same standards would be followed, but the system now is more detailed and more professional. Verify inclusion of all manuals, training delivery, seasonal testing, and review build. And this one, review building operations 10 months after completion. So you have now more stringent and more tough procedures, and there's a bit more check by a third party in the enhanced system commissioning, and you're going to get 3 points for that. To get 4 points, it's called enhanced monitoring based system commissioning. One step ahead, one step forward. Now all the commissioning, after commissioning, you have a monitoring based system. Usually the softwares, you can call it as building management system, which can generate hourly, annually, monthly, weekly reports based on the system there, that how these equipment and systems are performing, and you can compare output. So monitoring based procedures for systems and assess performance of energy and water consumption, mostly software based. So this is going to give you 4 points. For the documentation, if you're going for the first one, outline of training, confirmation of system delivery, and ongoing commissioning plan. Since this is now more professional, we would have a more detailed commissioning plan you have to submit. For monitoring based commissioning, team must also include, on top of what we have discussed, also include monitoring and tracking in commissioning plan. And you can also opt for the second option and combine the 2 points. Option number 2 for 2 points, complete commissioning process for buildings thermal envelope. How it's going to help? If you have a good thermal envelope and it is commissioned properly, it is designed properly as per the standards, and it has good insulation properties, it means that your air inside, which is cooled or heated based on your temperature and climate, it will not be leaked outside. If it is not leaked outside, it means less pressure on your HVAC system. Less pressure or less usage of HVAC system means less energy or electricity used. Less electricity used means less number of fossil fuels burned, and it will serve the purpose. For both the options, for the credit, commissioning agent cannot be, here comes again what I discussed in the prerequisite, that there should not be a conflict of interest. So commissioning agent cannot be an employee of design or construction firm, because if he designed the system and there is a flaw, there is a possibility that he will try to hide it and not to expose. And it cannot be a subcontractor of the contracting company, because he needs to get payment from the contracting company. They might play with each other. So it's an independent third party consultants or a firm, and it should report directly to the owner. Now for the documentation, for all documents which we have seen in option number 1, addition or on top of that, it should include the building envelope in the commissioning plan and should show a contract in place with the commissioning authority and the owner. Prerequisite number 2, minimum energy performance, asking us to achieve a minimum level of energy efficiency for building and its systems. There are 3 options to fulfill the requirement of this credit, but there are some constraints to it, and we're going to see it when we move along. Option number 1, whole building energy simulation except data center adaptations. We're going to see for data center as well. We have to show improvement by energy simulation and modeling, comparing our design case model to a baseline energy model that is established as per ASHRAE 90.1-2010 standard. We can make all this in eQuest, IES Energy Plus, or any equivalent software. So we have to show that we have improved on certain percentage comparing our design case model to a baseline model. One thing that we have to be clear about is that this improvement is on energy cost basis. So you have an energy usage in your baseline model multiplied by the cost of electricity there, and you have a total cost for baseline model. Then you have for design case the improved energy requirement there multiplied by the cost of energy, and then these total has to show a percentage improvement, and this percentage improvement is 5% in new construction, 3% for major renovation, and 2% improvement for core and shell. If you have any renewable energy in your project, will not be counted here. So prerequisite is that you have to show that you have achieved a certain percentage improvement in energy by efficiency of your systems and your design. Before we move on, let's have a look at energy simulation and modeling that we need to make our baseline energy model and our design case model. What we have to input inside? We have to input in our design case model lighting loads, HVAC loads, process loads, external loads, building orientation and location, and the software is going to manipulate it and calculate all the energy required or energy used by this design case building. You have to put plug loads, and this is also called unregulated load or miscellaneous load. It should be documented because you can never be so sure how many printers, how many scanners are going to be used, how many computers. So and this might fluctuate depend on the usage of the building. It's used as an office or whatever. Then there are escalators, elevators, etc. So these are called the plug or unregulated use. And sometimes it's not possible for the software, or the loads are not identical in the baseline and in the design case. So there is a special terminology that is called exceptional calculation method when simulation is not able to model the savings accurately because loads are not identical. So you put under the name of ECM or exceptional calculation method that there was a difference in between the design and baseline model, and it is balanced by exceptional calculation method. So for prerequisite number 2, option number 1, except data center, the documentation would be energy modeling inputs, which we have just seen, lighting loads, HVAC loads, ECM, etc. Modeling software reports, which modeling software you use and what reports are generated. Exceptional calculation method, if it applies. If you have put it inside in order to balance, then you have to show it here. Energy demand and consumption of the building should be submitted to fulfill the requirement of prerequisite number 2, minimum energy performance, option number 1. We excluded data center. Now let's see what's the requirement for data centers. First of all, for data centers there is no major renovation or core and shell, so 5% improvement is required, and rest of the requirements are same. But you can also make two energy models, one for building energy and other for IT equipment. We know that main electricity use or the energy use is for the IT equipment, so you can make two energy models for data center only. Now this is option number 1, including data center. There is option number 2, and the relationship is or. Either you go for option 1, or you go for option 2, or you go for option 3. So let's have a look at option number 2. Option number 2 is prescriptive path number 1. And as I said that there are some constraints when it comes to the other options. So the first one is that there is a surface area requirements that needs to be fulfilled. So in new construction and major renovation buildings should be less than 100,000 square feet. For retail it should be in between 20,000 to 100,000, and for healthcare should be more than 100,000 square feet. And these projects which qualify should comply and follow ASHRAE 50% AEDG Advanced Energy Design Guide, which is for service and water heating, in addition to ASHRAE 90.1-2010. So now the difference is that you do not have to make any energy model or baseline or case design, and no comparison required. You have to comply and follow these two standards, and you have to submit in your documentation that you have shown compliance with these two standards. And the second constraint for this option is that you can only pursue for option number 2 when it comes to the credit requirements. This is prerequisite number 2. So for the credits, there is again option number 2, and only you can follow that option, not the option 1. Now let's see the third option for PR2, minimum energy performance. Option number 3, prescriptive path number 2. The first constraint, the building should be less than 100k square feet, and it should not belong to school, healthcare, or warehouse adaptation. Now the energy target performance for these qualifying buildings must be established using Energy Star's Target Finder. Energy Star Target Finder is EPA, Environmental Protection Agency's online calculator that helps architects, engineers, and property owners and managers assess the energy performance of commercial building designs and for existing buildings. And at the same time, the score should be greater more than 90, and it should comply with mandatory and prescriptive provisions of ASHRAE 90.1. So ASHRAE 90.1 is common in all the three options. And in addition to ASHRAE 9.1, it should also comply with design process strategies of core performance requires from ASHRAE Advanced Building Core Performance Guide. So you have now two standards with ASHRAE, and also from the online calculator, score should be more than 90. But at the same time, the second constraint is that you cannot earn any point in optimized energy credits. The credit that is respective to minimum energy performance is optimized energy. We cannot earn any points if we choose to go for option 3 in the prerequisite. For the documentation, the Energy Star Target Finder results and confirmation that all aspects of Advanced Building Core Performance Guide requirement sections are being met. So we have option 1, 2, and 3. For option 1, it's more wide and open. Option number 2, you can only claim for, or you can only opt for option number 2 in optimized performance. I mean, if you go for option number 3, you cannot claim any credits or any points in optimized energy performance. Credit number 2, optimize energy performance. 1 to 18 points for all adaptations. For school, it's 1 to 16. For healthcare, it is 1 to 20 points. So if you have opted for option number 3 in minimum energy performance prerequisite, you have already lost these potential points. The intent is similar to PR number 2, minimum energy performance. The requirement is to establish energy performance target no later than schematic design phase in kilowatt per square meter per year. Now we'll see how to fulfill. The first one is whole building energy simulation, which can give you 1 to 18 points. It's the same that you have to show the percentage improvement than the prerequisite. The prerequisite was to start with 5% when it comes to the new construction, for major renovation 3%, and for core and shell 2%. So you have to analyze the efficiency measures. We're going to see it in the next slide what we can do, and the teams which are pursuing integrated process credit must complete simple box energy model that we just discussed previously. The documentation is in addition to the PR prerequisite to option number 1 documentation. Renewable energy savings should be specified, if any. If you remember that renewable energy was not included in the prerequisite, and you should claim all this energy saving based on your design. Now let's have a look at the number of points that we gain based on the percentage of the savings we do in our project. This is the table that shows the percentage improvement based on cost and the number of points that you can gain. So if you remember, for new construction it was 5% prerequisite, for major renovation 3, and for core and shell 2. So respectively, if you start from 6% new construction, 4% major renovation, and 3% for core and shell, you start gaining the respective points, and you can go up till 50% for new construction, for major renovation 48, and 47 for core and shell, and you earn respective points as per this table. So it has too much potential to earn points in this particular credit, and preferably you have to go for option number 1 in the minimum energy performance. These are some energy efficiency strategies that you can implement in order to make these savings. You can use load reduction, improve mechanical system efficiencies, building orientation, tighter envelopes so there is no leakage and there is less use of HVAC system, lighting system efficiency, increased insulation. So these are all the things that you can do in order to achieve this much savings and in turn this much points. Option number 2, prescriptive compliance. These are for the project teams who opted option number 2 in PR2, minimum energy performance, and they can earn 1 point for each of the following as per standard ASHRAE 50% advanced energy design guide. So based on all this, they can earn 1 point each if they are able to reduce as per this standard. The details are there inside the standard, and for the documentation you have to show compliance as per ASHRAE 50% AEDG, and you can have 1 bonus point as exemplary performance. If you remember, as per the table, 50% of savings were shown and there were respective points, but if you're able to show 54%, you will earn an extra bonus point. Prerequisite number 3, building level energy metering. You cannot improve what you cannot measure. Concept similar to water metering that we have just gone through, to identify opportunities for additional energy savings, in this case by tracking building level energy use, and the requirement is to install new or use existing metering system for all energy needs like electricity, gas, chill water, steam, fuel, etc. And you have to share 5 years of metering data with USGBC. It should be a commitment. If the meters are not accessible, you can use the monthly bills to track usage. And just like the prerequisite in the minimum energy performance, the renewables or any on-site produced energy will not be counted in the prerequisite. It will be dealt in the credit. So for the documentation, list of all advanced meters to be installed, you have to show it to the GBCI. They type an energy source that is metered. So you have to share basically the metering data with USGBC. Respective credit number 3, advanced energy metering, 1 point for all adaptations. What we did in water meter, we have to do the same. We have to submeter the system, install for whole energy sources and submeter for any individual energy source that use 10% or more of total consumption. But these meters that we are going to install in advanced energy metering should have some advanced characteristics as well. They should be permanently installed, must be able to record and report early, monthly, annually. Data collection system must use LAN, BMS, wireless, and remotely accessible. Electricity must record both demand and consumption, and it should be able to store, the meters should be able to store 3 years of data. So it's kind of advanced. First of all, you have to meter all energy system, any energy system that takes more than 10%, and these characteristics should also be there in the meters. So the documentation is to provide location of all submeters and main meters, list of them, and the letter of owner's commitment that you will share all this information with USGBC. Prerequisite number 4, fundamental refrigeration management. The purpose is to reduce the ozone depletion and to show compliance with the Montreal Protocol. I have discussed in detail the ozone depletion potential, the global warming potential, the Montreal Protocol, the CFCs, why they were banned, everything you can watch in that video to have more idea. The requirement for this prerequisite is that you cannot use CFCs or chlorofluorocarbons for new HVAC system. It is banned under Montreal Protocol and it's not acceptable. And if you are going for any major renovation project in which the equipment is installed which use CFCs, you have to have a phase out plan, and it should be dated that you would stop using any system that use CFCs by that date. Apart from that, small water coolers, standard refrigerators that use less than half pounds of refrigerant of CFCs and any similar appliance might be exempted from this prerequisite requirement. But the idea is that Montreal Protocol bans CFCs, so new systems should not use it. For the documentation, you have to submit the list of equipment that are using the CFCs, confirmation that the new equipment you are buying is not using CFCs or using any other refrigerants, and in case you are going for a major renovation project, there should be a phase out plan dated that by this date you will stop using CFCs. CR4, enhanced refrigeration management, prescriptive credit to PR3 we have just seen. Intent similar requirement is to choose refrigerant based on low GWP and ODP. We know GWP is the ratio of global warming for any substance compared to carbon dioxide, providing they are of the same mass, and for ODP the standardized gas is CFC 11. We also discussed that ODP is more potentially dangerous, so for the new refrigerants that we have to use in our project as per the option 1 of this credit, the ODP should be 0 and GWP should be less than 50. If we are able to show that, no calculation is required for the documentation, a confirmation that only low impact refrigeration is used, which is ODP 0 and GWP less than 50. This is one of the options. The second option is to go for the calculation method or calculation of refrigerant impact. Whenever calculation is involved, things get a bit more detailed. If you remember, there was bug rating and the calculation method, and there was the water sense fixture or appliance used, there was a calculation method, and similarly we have calculation method here, and I think more to come in materials and resources. So it will be a bit more detailed. You have to go one by one. There will be a complex formula as per even the study guide. The formula is so complex that it is highly unlikely that it's going to appear in the exam. So the combination of new and existing HVAC and refrigeration equipment in project must comply with that complex formula that I have just told you about. Just to understand a bit about the formula, these are the factors that are required or has to be input in the formula. This is life cycle ozone depletion potential, life cycle global warming potential, refrigerant leakage rate, refrigerant charge, and equipment life, which is 10 years by default. So it's a bit more detailed, and if you somehow you have to go deep into that and you put all these values in the formula and it comes below the requirement, you will earn 1 point. The retail projects have commercial refrigeration systems, the one you can see below in the figure as well. The bigger the system, the bigger the tubing. The bigger the tubing, more the refrigerants are inside. And there is more potential of leakage. And if there is any leakage, more refrigerant, which is ozone depleting, will be into the atmosphere. So, particularly for retail projects where big systems are used and there is a high potential for the leakage, there is a certification program by EPA or Environmental Protection Agency called Green Chill Certification Program, which recognizes individual stores for using the friendlier and commercial refrigeration systems. So this Green Chill Certification Program has 3 levels. It has silver, gold, and platinum, and any retail project can apply for free in any stage of their project for this certification. For the retail project, they can either go for the first option, do not use any refrigerant with the ozone depletion potential or GWP less than 50, and in the other case they can have the Green Chill certification program. And for the documentation for the option number 2, which was a calculation method, a bit more detailed one. So you should have a list with the equipment type, their capacities, their refrigerants, their charge and equipment life, and certainly for retail we have just discussed. Credit number 5, demand response 1 to 2 points in all adaptations. If you recall, first demand response this terminology came in the credit green vehicles, where you had to put the EV charging stations, and these charging stations should be capable to take part in demand response program, and we said that we will discuss it in energy and atmosphere credit category. So here we are. The intent is to increase participation in DR tech that makes energy generation and distribution system more efficient. How does it do that? Basically, the energy is required more by the consumers, and utility is not able to provide all. So this figure kind of explains that in the process or in the event when there is an increased load or increased pressure or increased demand from the consumer in the power grid, it sends a signal via power lines carrier, radio signal, or internet to the consumers that we have an increased demand situation, and the consumers have their systems in place where they can reduce some of the demands, and in case turning the load down from the utility provider. So what are the requirements of this demand response program? We'll see it in the next slide, but we have understood what is why demand happens certain parts of the or certain part of the year and certain part of the day. The energy demand is much more, like cooling capacity or cooling requirement is more on hot days, and vice versa. So based on these situations, there is load on the power grid. They send a signal, and consumers shed some load out of their system in order to balance. Now let's see the requirements. The projects must be participating in the demand response programs, and in case there is a DR event generated by the utility provider, the project must be able to shed or shift minimum 10% of estimated peak electricity demand, and renewables do not count here. And all this process of shifting and shedding should be done automatically in order to gain 2 points. There is a possibility of manual, but not for this credit. For this credit, it should be automatic shifting. And if there is DR program not available in the area that your project is, you can provide the infrastructure from the building side, that if in future they implement the DR program, you are ready for it, and you gain 1 point for that. Some strategies for load shedding could be increase cooling set points for entire facility, vice versa. You can turn off some features that are solely decorative, or even if shutting them off will not affect the normal operation of the building, like fountains, video displays, or some decorative lights even. And you can reschedule in the demand goes high in a certain time period, so you can reschedule some activities such as dishwashing and laundry in healthcare and hospitality, where it uses so much energy. So these are some strategies in order to respond to a DR event. The documentation is to show the proof that you are enrolled or participating in the DR programs at least for 1 year, and the evidence that you are able to shed 10% of electricity, which is the main demand of this credit, and the proof that system can respond automatically. If these 2 requirements are met, you're able to get 2 points, and in case of DR event available. If not, you can get 1 point. Credit number 6, renewable energy production, 1 to 3 points for all adaptation. Remember, this is what the on-site production of energy we are talking about by the renewable. So the intent is to reduce the environmental impacts associated with the fossil fuel energy. We know that when the fossil fuel is burnt, it releases the greenhouse gases that contributes to the global warming. So if you are making an on-site renewable energy and you're offsetting, is based on the requirement, if you use a renewable energy system to offset building energy by percentage, and now this percentage is based on cost. Now, from where you can get the total energy consumed by the building, if you recall minimum energy performance, the first whole building simulation, that tells you how much energy is required by your building, and you can respectively take out the cost. So you have to offset the building energy usage consumption based on cost, and these are the acceptable renewable energy production on-site: hydropower, biofuel, solar, biomass, wind, geothermal, and from the waste. So if you are producing on-site energy with these facilities and you're offsetting a percentage of building energy usage by cost, you're going to gain some points. We're going to see in the next slide how much percentage is going to earn how many points. So as per the table, if you are able to show that you have offset 1% of building energy cost by renewable energy production on site, you are able to gain 1 point for all adaptations. There is a little bit change in core and shell, but the maximum number of points you can earn are 3 up to 10%. And this is the formula that you can use. But in order to justify these percentages and justify this formula, you can submit a documentation that shows the on-site renewable energy production with rated capacity and this calculation and cost of energy produced compared to the total cost, which you can get from whole building energy simulation. Credit number 7, green power and carbon offsets, 1 to 2 points in all adaptations. This is an interesting concept. If you know that the utility that provides you with the energy or with the electricity, there could be multiple sources. One source could be a fossil fuel burning that produces electricity and put it onto the grid, and the other could be renewable. But once the electricity has been put on the grid, you cannot differentiate that which electricity is being produced by a fossil fuel or which electricity is produced by any renewable setup. So what you can do is that if you can purchase an REC, that is called Renewable Energy Certificate, it is like you buy the rights of that energy that is produced by any green power source. So you use electricity and then you purchase an REC, the Renewable Energy Certificate, which certifies that you are the one who used the renewable energy from that grid. So it means that you are using the green power. When it comes to the carbon offsets, it's like you are producing the carbon on your site by any like space heating, or if you're burning any coal oil on the site. These carbon footprints or these carbon emissions can be offset by some other activities taking place in some other parts of the world, which is reducing the carbon emissions. For example, if they are foresting, it is reducing the carbon from the atmosphere. If they are putting any project that is producing the renewable energy, it means that they are offsetting the energy that could have been produced by the fossil fuel energies. So the green power is rated in megawatt hour units, and the carbon offset is shown in metric tons of CO2. So after understanding the green power and carbon offset concept, so the intent is to encourage project owners to financially support off-site renewable energy production in green power or any other activity that reduces carbon emission, which is carbon offsets. The requirement of this credit is that you should have a contract of minimum 5 years to purchase at least 50% of your energy requirement based on the consumption, not on the cost, because all what we have seen so far in for example in the renewable energy, it was based, or offset was based on cost, but this one is based on consumption. That based on your consumption, your energy should be purchased at least 50% by a green power, carbon offset, or a renewable energy certificate. Now a renewable energy certificate is required maybe when you have a mixed utility where you have a green power and you have the fossil fuel power, but there is a possibility when the utility provider is using the sources only that are green, like wind turbines or PV cells. So this would be a green power. You don't need to buy any certificate, but this green power and REC should be certified by Green E certified and carbon offsets by Green E climate certified. That shows that all the requirements for green production are met. If you are able to show 50% energy requirement is purchased by green power or other sources, you can get 1 point, and if you are able to make 100%, you can get 2 points. Now it says that REC can mitigate scope 2 and carbon offset can mitigate scope 1 and 2 emissions. What are these? Scope 2 emissions are those carbon emissions or greenhouse gas emissions which are beyond the control of the project. If you are buying an energy from a utility, this energy is produced by the fossil fuels, which releases the greenhouse gases in the atmosphere and contribute to the global warming. But this is not under your control. So REC can mitigate only scope 2. But in case of carbon offsets, it can also mitigate the scope 1 emissions, which is directly under the control of the project. If you are burning any coal on the project for space heating, this is disqualifies as scope 1 emissions. Now, why they are important? Because if you're going for carbon neutrality or carbon reduction, you need to buy these certificates to show, because now you cannot go, if you want to go carbon zero, you cannot go right now because you are using some facilities or using energy which are releasing the carbon in the atmosphere, and there are carbon emissions. So in order to mitigate that carbon emissions, you can use RECs or carbon offsets. So for the documentation, you need to provide an annual electricity and non-electricity usage, REC carbon offsets for the targeted point, or 50%, 100% you have to show, and you should also show the contract letter that shows the 5 years contract is there in place to fulfill the requirement. With that, we come to the end of energy and atmosphere, and I hope that you will continue to the next video. Thank you.